Welcome everybody on this second day of Tech Days. I hope you had a good time yesterday and a lot of coffee this morning. And welcome to this session in the Windows Phone track. This is a session on application lifecycle, isolated storage and local database. Now, you might wonder how these are connected. Because, well, application lifecycle, that's about the execution model governing the lifecycle of your applications. So that's what happens when you go from running state to dormant state to tombstone state. And then there's isolated storage, that's to save data. And local database, that's another way to save data, related data. Well, actually they're quite connected because when you're going through the life cycle of your application, you want to have a mechanism to save state. So the user, when he returns to your application, still gets the feeling the application is left in the same state as before. So you need somewhere to save that state. That's where isolated storage comes into play, and that's also what you can use a local database for. Now I'm going to start by introducing myself. My name is Kevin. I'm a technical consultant and solution manager at Real Dolmen. That's a Belgian firm. I come from a .NET web stack, actually. I've been programming C# web applications, ASP.NET, for quite a while. And afterwards I migrated more to Silverlight, and well, then Windows Phone is a bit of a logical step to be doing now. I've also written a book. Well, this is the second one. It's due in March, and it's a book I've written with a colleague of mine on Silverlight, mainly on creating line of business applications with Silverlight. So it's not the typical, well, how do I put a control on my page stuff. It's about accessing data, and well, actually it's full of recipes for creating line of business applications. And it includes the Windows Phone chapter. And I promise that's all the commercial stuff I'm going to put in this session. So what are we going to talk about today? I'm going to start with an introduction on what the Windows Phone Mango application lifecycle is, and what we use it for, and why it's so important to get this right. And we're going to look into the different events and states that you get when you work with the application lifecycle. After that, we're going to build a small application throughout this session that will get better and better in each demo, or at least I hope, by taking all the states and events from the application lifecycle into account one by one. So we're going to start by having an application which is actually quite bad because it doesn't do anything with the application lifecycle, and one by one we're going to try and make it better. So after I explain the application lifecycle events and states, we'll look into how we can improve the application by using isolated storage to save state between different instances of my application. And we can see what we can do to further improve the application. So we're going to look at threading, multi-threading, getting big tasks on the background thread so the user isn't blocked, and storing state in between, so not only at start and end. And after that we're going to talk about the isolated storage database. That's a new feature in Mango. It will be very familiar for those of you who once worked with Link to SQL, because it's actually using that same logic in that same part of the framework. So that's a database stored in your isolated storage used to save related data. And of course we do need to talk a bit about limitations and differences, because it's an isolated storage database. You can't just expect it to be able to do the same as your local SQL Server instances. To end, I've got one slide to help you choose between choosing a regular isolated storage to save state or the database, and some time for conclusion and Q&A, I hope, because there's quite a lot of content and I will have to be fast. But if you've got questions that I can't answer during this session due to time constraints, just send me a mail afterwards or on Twitter, and I'll try to answer you. Okay, first slides. I'm going to do a bit of talking and then I'm going to go into the demos. Of course, the execution model governs the life cycle of the application. The execution model, that's what happens when you go from one state to another, and it's logical that that's governing the life cycle of your applications. But why is this so important? Well, a user should always have a fast and responsive experience. When you're going to design an application for Windows Phone, you probably want it to become popular, I hope. The problem is there's probably tens of applications out there that do the same as yours. Unless you've got a killer idea, most of it has probably already been thought about. Now, how can you make sure your application stands out? That's by ensuring the user experience is good. In Windows Phone applications, user experience is almost king. If you don't keep that into mind, well, users will switch to an application of the competition that does the same, or even does less but offers a better experience. How do you get this faster and responsive experience? By taking into account the application lifecycle. By taking into account what can I do when the application starts, and how can I do this? I shouldn't load too much data when the application starts, so I do that on another thread, stuff like that. Now, there's also no true multitasking in a Windows Phone, or actually in any phone operating system. But the application lifecycle helps to create this illusion. The application lifecycle ensures that your application can go into a dormant or tombstone state. I think probably most of you already heard about that. And you, as a developer, are responsible for getting the state back from somewhere, putting that back into your application, so that when the user returns to your application, he gets the feeling the application has been running in memory all along, all the time. So he gets the feeling his application has been running in the background, while in essence it was already removed from memory. So to do this, we're going to use application lifecycle states and events. So actually it's all about delivering a good experience to the user, most of this. Probably the most important slide of my slide deck. So I'm going to keep this on for a while. This explains all the events and states you will have in your application. The three big green dots, let's say big green circles, those are the states. Regularly you will be in running state. Your application launches, that's the red one on top. You navigate between pages, those are the two blue ones. And while you navigate between pages, you will always go to the unnavigated method of a page or a view, go to running state, keep in running state, go to another view, keep in running state. That's the regular usage of your application. Now, on the bottom, there's two other important events. It's application deactivated and application activated. These are the ones that take most of the work, and these are the ones that we use to create the multitasking illusion, let's say. When you move forward from your application as a user, so you've got your phone application, you move forward. Moving forward means you launch another application, typically. So the user is in your app and he launches another app, or he goes back to the start screen. That's moving forward in your application. Well, your application automatically gets deactivated. So you end up in the deactivated event. And then two things can happen. Once you go into the deactivated event, your application is automatically put in dormant state. That's a new feature in Windows Phone Mango. And that's probably the easiest one to be in. Because dormant state actually means your state information. So the values of your view models, the values of your variables, is just kept in memory. And when the user returns to your application, so it goes to the activated event, you don't have to do anything. Your application will be there just as you left it, just as the user left it. So that's the easiest one. The problem is you don't have control over this. Your application is put into dormant state, but once the operating system thinks it needs more memory, or the user launches a few more applications, your application goes from dormant state to tombstone state automatically. You cannot control that. That actually happens automatically. So you're in tombstone state, and the problem with tombstone state is your app is no longer in memory. A few things are saved, but not your complete application, because, well, the operating system needs memory. So once you're in tombstone state and you go back to the activated event, the user returns to your application, you no longer have your state automatically. So that means in the deactivated event, you need to save state somehow. As long as you keep in tombstone state, there's a dictionary, state dictionary built in, and that state dictionary is saved and persisted as long as you're in tombstone state. So that's the second thing you can do. You deactivate, go to dormant, nothing has to happen. You go to tombstone state, you cannot control that. So that means in the deactivated event you have to use the built-in state dictionaries from Windows Phone to save your state. So when you're activated again, this state can be brought back from the state dictionaries and put into your application again. So again, the user gets the experience that his app has been running in the background all along, while in reality it's been removed from memory. One more problem. You can't control whether or not you stay in tombstone state either. So when the operating system decides it needs even more memory, I think there's a limit of about 5 applications that can be in that state. After more than 5 applications are in that state, your application is completely removed from memory. That means not even the built-in state dictionaries are left available in memory. Your application is essentially terminated. The same thing that happens when you close your application through the closing event. So that's not a problem we need to keep into account. A user can move forward, just launch another application. Your app goes in the dormant state. After a while, the operating system decides your app has to go into tombstone state. And after a while, the operating system can decide your app has got to be terminated because more memory is needed. So that's 3 things you need to keep into account. That means we need to not only work with the dormant state, so do nothing, work with tombstone state, so save state in the state dictionaries, but you also need to keep into account that the application can be totally removed from memory. So if you want to save state, then we need to use a mechanism like isolated storage to save state and load it again when the application launches. So that's 3 things that can happen when the user moves forward. The user can also move backward. So that means he starts your application, works with it, and presses the back button a few times until he moves past the start page of your application. That's moving backwards. Your application won't be deactivated and won't be activated again. Your application will end up in the closing event. So your application is immediately terminated. That's another place where you should save state to typically isolated storage. That's the same logic should happen in the closing event than what happens when you get deactivated and take into account that your app can be totally removed from memory. That's probably the most important slide of my slide deck, which explains the 3 different states you can end up in and how you can end up in them. I will, of course, explain this in the demo in a few minutes, so everything becomes a little more clear. Those are the states. Now, what about those 4 events? The launching event, closing event, activated and deactivated. Those are the 4 events you have to keep into account. The launching event fired when a new instance of your application is launched by the user. That's the user starts your application. User expects a fresh instance which starts up quickly. So when you go into the launching event, you should never ever try to get your user to where he last left off in the application. When you launch your application, a user expects a new instance of the application, not an instance that left somewhere halfway through the application. And it should start up quickly, so you cannot load huge amounts of data when you launch your application. Well, at least you cannot do that on the regular thread. So code should not take a lot of time, and you should, of course, avoid all resource-heavy tasks. But you can work around this by loading your data on a background thread, which I will show you. Very important here, there's a 10-second limit. This 10-second limit applies to all the events I'm going to talk about. So launching, closing, activated and deactivated. The code that happens in that event on the same thread, once it takes more than 10 seconds, your app will be terminated, removed from memory, done. So you really need to take into account that it shouldn't take long to go through those events. And even then, if it takes 10 seconds to start up an application, again, the user will go and look for a competing app, I think. And we've got the deactivated event. Talked about that. That's when the user moves forward. It's also fired when the launcher chooser is executed, by the way. But that's typically what happens. The user moves forward to an application, your app is deactivated. What you should do here is, when you go through the deactivated event, I've talked about this, a few things can happen. Dormant state, tombstone state, or completely removed from memory. So you should store the app state in the state dictionary, which we use when returning from tombstone state. And you should also store your application state in your isolated storage, which we can use when we return from an app that's terminated. You might wonder why. So why would I want to store it in the state dictionaries, to built-in state dictionaries, when I can just store everything in isolated storage and get it back from there all the time? Well, these state dictionaries are actually faster. These are kept in memory while isolated storage is written to disk on your phone. So if you can, just use the state dictionaries. That will be faster. And we've got the activated event. That's what happens when the user goes back to your application, which is dormant or tombstoned. What we should do in this is we should check if we're coming back from a dormant or tombstone state, which is what the isApplication instance preserved variable is for. And depending on what we're coming back from, we should do either nothing. When we come back from dormant state, everything is saved by default. Or we should get our data and state back from that state dictionary we just saved it in. Again, no resource-heavy operations. That stuff should be done on a background thread. And also the 10-second limit applies here. And finally, we have the closing event, which fires when the user navigates backwards past the first page of an application, where application is actually terminated. So storing in the state dictionary doesn't matter because, well, if your app is terminated, that state dictionary is removed from memory as well. So here your only option is to actually save it in your isolated storage, or an isolated storage database, of course, if you want to persist state. Right, that was a lot of talking and a lot of slides and a lot of information, I think. So I'm going to try and go through a demo to show you a few things. Right. I'm going to make this a bit bigger so you can all see. I'm quickly going to explain the application. It's a very simple one, but it serves the purpose for this demo. Let's start this up. Probably going to end up in my breakpoints. That doesn't matter. It's a very simple one. You've probably all seen this. There's a reason why I keep it this simple. It's simply because the focus is on the application lifecycle and not on the app itself. So I've just got a list of data, dummy data, which I can edit. And by the way, quick tip, if you're working with Windows Phone and you don't want to type with that keyboard in the emulator, just push pause break on your system. And then you can type with your regular keyboard. Let's see. So I've got an application up and running which fetches a to-do list, and I can edit my items, I can add a few items. But there's a few problems with this application. Because let's say I exit the application. I should do this like this. I exit the application and let's start it up again. My changes haven't been saved. So I just edited dummy3, changed the description a bit. My changes haven't been saved. There is no state saving in this application at the moment. So we're going to try and make that a bit better. Now the application has been built with the model view model design pattern. There was a session on that yesterday. It's pretty much the de facto standard when building XAML applications. So Silverlight WPF, Silverlight for Windows Phone as well. You guys know about MVVM? Yeah? Okay. If you want some explanation, that you can just come and ask me afterwards, but I think most of you will probably know about this already. A pretty good library for this, the one I prefer is MVVM Lite. I think you probably know that one as well. It's from Laurent Bignon. It's actually a guy who's also at quite a lot of sessions talking. And I like it because, well, it's pretty lightweight, it's open source, and it's not filled with clutter as some other libraries are. The easiest way to manage that one, to manage external dependencies in each application actually, is NuGet, in my opinion. Just in case you haven't heard about that one before, it's actually a plugin for Visual Studio, let's say, with which you can manage external dependencies. So a lot of applications have need for external libraries, but these external libraries might have dependencies on other external libraries, which in turn have dependencies on other stuff. It becomes quite a hassle to keep all that in check after a while. NuGet solves that for us. NuGet is something that ensures my dependencies are up to date, and dependent dependencies from libraries you're using, quite a lot of dependencies in that sentence, are automatically added to your application as well. That's just a quick tip, doesn't actually have anything to do with the Windows Phone app. Okay, so let's talk about my state a bit. I've created a local store. That's actually a class which holds my data to easily access it. In it I've got a list of to-do items, I've got a current item, and on initialization I can pass in a boolean which states load my dummy data. I will only use this when nothing is available in IsoStore or something. Which then simply adds a few dummy to-do items to a list and takes the first one as the current one. So that's really, really simple data store. And how does this work? I start my application, I get into the launching event, and I initialize my local store. Problem, nothing is saved when I exit the application. So I move forward, I launch another application, I go to the deactivated event. Somehow I should be able to save my state here. Because as we know, when my application gets activated again, I can be in a dormant state or I can be in a tombstone state. So let's try and test this dormant state first. It's actually pretty easy. Let's see. Okay, I can edit one. There we go. Confirm. I navigate away from a page. And now I move forward. So, my application gets deactivated. There's nothing I do here. Now I move backward. So my application gets activated again. And my state is saved. Now, why is this? Because my phone operating system automatically put my application in dormant state. I only have one app running on this emulator, so there's no way it's going to put it in tombstone state automatically yet. Of course, tombstone state, that's something different. Then my state won't be preserved. So now we need a way to check for tombstone state. And first of all, to debug this, we need to get to tombstone state, of course. As I said, the operating system decides this for you. It decides automatically when it goes from dormant to tombstone state. So if we need to test this, we could say, okay, launch the emulator, launch about 5 other applications which take up a lot of memory, and hopefully my app will end up in tombstone state. That's not very convenient, and that takes a lot of time. There's a trick for that. If you go to your project properties, in the debug tab, there's a checkbox you can click, tombstone upon deactivation while debugging. This means that once I get deactivated, my application will automatically go to tombstone state. So like this, I can easily check this and test this. Okay. Now let's see what happens if I run my application without doing anything to preserve state. while going to tombstone state. Okay, I confirm. I move forward, so my app is deactivated and I do nothing. And I move backwards, so I'm activated again. And now, there we go. Why is this? I am returning from tombstone state, but I did nothing to save my application state, while my app does rely on that application state to be there. My application relies on that list of to-do items to be there somewhere in memory, somewhere in the class. I've built my app like that. But due to the fact that I'm returning from tombstone state, all that has been removed from memory. So I need a way to save this state. Okay. So in application deactivated, what am I going to do? I'm going to use phone application service.current.state. That's the built-in state dictionary I was talking about. I pass in a key and I pass in some data. That local store, that's actually my class instance which holds my list of to-do items. So that's the full application state I'm saving here. So when my app gets deactivated, that's put into that state dictionary. When my app is activated again, I of course need to do some stuff as well. I need to get that data from the state dictionary and assign it back to my application. And that's actually this code. First thing, you need to check if you're in dormant or tombstone state. That's what this check is for. When we're in dormant state, as I've shown you, we do nothing. When I'm returning from tombstone state, I get, or I try to get the key I just saved. And I state, well, my local store is the local store instance I saved when my app got deactivated. And if all goes well, let's see, can I edit this? There we go, confirm, deactivate, I save into the state dictionary, and back. I'm activated again. This should be false, as it is, because I've checked that tombstone upon debug check in my project properties. And there we go. As you can see here, the changes I made to my data are saved. And my app still runs and doesn't crash. That helps. It's quite important as well. Okay, so what have we done up until now? We have worked with tombstone state, we have worked with dormant state, deactivated event, activated event. But there's still a problem, because this all works as long as some parts of my app stay in memory. The full app, or at least state dictionaries. But what happens when my application gets completely removed from memory? My state still isn't saved. My state is not saved between different application instances. That's what I need isolated storage for. Nice thing is, if you're used to working with Silverlight, you know that there are quotas on isolated storage. Those are not available. Well, there are no quotas on isolated storage in Windows Phone. Well, unless you count, of course, the disk space on your phone. What can you use this isolated storage for? Some people use it for temporary data. So data that's used throughout your application, but should probably be removed when you exit the application. It can be used for user-generated data. So if you have an application that generates some documents, you can save those in isolated storage. Isolated storage of an application is only accessible by that application. So you've actually got a store to store documents available for your app. Of course, it's also used for application data, typically your application settings, the number of items in the list, for example. And of course, the part we're going to focus on, it's often used to persist state between different sessions. Now, there's two ways of working with the isolated storage. You can use the isolated storage file and file stream, which is actually just as you're used with the file class, writing files to and from isolated storage as you would on your disk. But you can also use the isolated storage settings. Now this is a personal preference, but I almost always use the isolated storage file. I write my stuff to a file and then fetch it back from that file and cast that to the necessary, or parse that into the necessary classes, which I can then bind to my UI. Isolated storage settings, on the other hand, those can be bound automatically to your UI, and they will update as well. So that's one of the reasons why a lot of people prefer to use that. Why don't I? Well, actually, I prefer to have a little bit more control of where I put my data. I store my client-side model, let's say. And it's also important to notice that the isolated storage settings are not thread safe. They can be used, but keep that in mind. Also, you need to call the save method on those isolated storage settings because it does not always save in between. So that's quite important to know. It's usable, it's easy, but there's a few things to keep into account. So I actually prefer to use file stream. Now we're going to improve our application. Now we know about the isolated storage. We need to save our data in isolated storage when our app gets deactivated. And we need to save it in isolated storage when the app is terminated, of course. So when the user navigates back before the start of the application. And on launch, we're going to fetch that data from isolated storage. So my state is actually persisted between different sessions now. Okay, to help me with this, I've written a small class called an isolated storage manager. That's actually just something I use to make it easier to save data into my isolated storage and fetch it from it. Simple typed class you can use to store elements of a certain type in your isolated storage. What will happen is it gets the user store for this application, so scope to my app. It opens a new file stream and it serializes my object to that stream. So now my object is saved to the isolated storage. To fetch it again, I just call the retrieve function, which will automatically get me a typed result back. I look for the file name which I ask for. I open a file stream. I again use data contract serializer to read a file of that type, and I return my data in a typed format. That's actually just a helper class, but makes my life a bit easier. Okay, so improve on my application. First, my app gets deactivated. So what do? I not only save my data to the state dictionaries, I also save it to the isolated storage, to the demo.txt file in my case. That's the first thing I need to do. This means that when my app is totally removed from memory, I still have that data. That's the first place where that can happen. The second place where that can happen is, of course, when the user totally exits the application. So that's the closing event. Let's find that one. There we go. And also let's uncomment that. Exactly the same code as I used in application deactivated. So with this in place, I know my state is persisted to the isolated storage. Now I need to, of course, get it from isolated storage. And when do I need to get it from isolated storage? Only in the launching event. So I do not need to do this in the activated event, because when the app is removed from memory, you will never get to the activated event anymore. Your app will be launched as if it were a new app. So let's comment this one out first. I try to retrieve a file typed from my isolated storage. If it exists, I use that as my local store. If it doesn't exist, I initialize a new one. Okay, that's about it. Now let's see if this runs. It builds. It's already good. We start up. First time, there's nothing in my isolated storage yet because I haven't saved anything. So I initialize a completely new one. There we go. Let's edit this one. And confirm. Breakpoint. And now I can do one of two things. I can deactivate my application or completely exit it. It's exactly the same code. Well, as far as isolated storage is concerned. So let's deactivate my application. Save to the state dictionaries. We don't use that for this demo. And I save to isolated storage. And there we go. And now if all goes well, I quit my application. I start it up again. So this is definitely a new instance. And normally, the local store I got from isolated storage now actually contains something. I reuse that one. And as you can see, my data is still here.
Can you somehow browse the isolated storage with the tool that comes with the SDK command?
There is a tool that comes with the SDK to look through isolated storage, but there are actually better ones available on Codeplex. There's an isolated storage explorer on Codeplex. That's a lot easier to use for that. Because the tool that comes, it's command line typing. I think there's actually about three different ones available on Codeplex just to browse through your isolated storage. A small tip, by the way, if you want to clear your isolated storage, the emulator automatically clears it when you close it. So if you're testing your application and you're thinking, whoa, something should be in my isolated storage, but it isn't there, or oh, it should be cleared, but it's still in isolated storage, remember that when you quit your emulator, the isolated storage is also completely cleaned out. Okay, now this is good, but it can of course be better, because imagine that this is a long-running operation. I'm loading 10 items from my isolated storage from disk. That's done in a few milliseconds, let's hope. But this might be a lot of data that can be loaded, that should be loaded at launch. Then you should use another thread to do that, and that's what I'm going to do now. Let's uncomment this, and I'll quickly explain it afterwards. So there's a background worker class included in Windows Phone. And this background worker, that's a very easy way to get some operations running on another thread. So what I do here is I just create a new instance of this background worker. I say, well, to do work event, in the background thread, you should retrieve my data from isolated storage. And once that data has been retrieved, well, you should actually do, well, take the data you get from isolated storage and use it as the local store for my application. And afterwards, I just send around some messages to respective view models to tell them my data has been loaded. So that's actually just a few lines of code. And what happens here is exactly the same as what I did before, just on another thread, on the background thread. This ensures my application is faster, more responsive in the beginning. on launch because we're running stuff on another thread. Let's see if this actually works. See, I'm in the background. There's still some data in my isolated storage, of course. And there we go. I loaded my data on a background thread on application launch. So that's that. What else? You can go a bit further even. At the moment, I am storing my state when the application gets deactivated or when we exit. The application closes. Now, there's a 10-second limit on that. Imagine you have a lot of data. A huge data store. It can happen. There's another place where you can store your state, and that's storing it in between instead of only at close and activation. That means you store your state when the pages, when the user navigates between pages, instead of when the user exits or deactivates your application. That's another thing you can do. Should you do this? Well, it depends. As with everything, it depends. If you store your state between pages, you really should take into account that what you save in the page navigated from event should be small pieces of data, because else the user will have to wait too long before he's navigated away from the page. Or you can, of course, use, again, a background thread to save your data. So let's have a look at how that's done. Okay. Instead of saving my state in the deactivated event or in the closing event, so I need to comment that out again. Where's the closing event? There we go. I now save state when I navigate away from a page. When I navigate away from which page? Well, in my case, it's the page where I can edit items, because that's the only place where I save, where I can change something about my state. So that's the one item view. And on the navigated from event, that gets fired when I go to another page. Actually, when I push the confirm button, I navigate afterwards to another page so that this gets fired. And this is where I save state. There's one thing you need to check here. You need to check if you're not going backwards, because the user can go to the edit page and press the back arrow. That, of course, should not persist any changes. The user navigates back. That's like a cancel button. So you check if the user's not navigating backwards, and if he isn't, you can save state. Like this, you work around the 10-second limit in the closing the activated event. Let's see. Let's edit this one again. Oh, right. Test. There we go. Confirm. I'm in my navigated from event now, and I save state here. And normally, if I now exit the application, just stop debugging, I don't even come into the closing event. This can actually never happen on regular usage. My state is still saved, because I've now saved it in between. Okay, that's another technique. What else? Up until now, we've already used the background thread to load, so the launching event gets finished fast and the data is loaded on the background thread. We're now using the unnavigated event from to save state, so the activating and closing won't time out. So that's another technique you can use. But is there even more we can do? Because these are all techniques. Which one you use depends on your application. If you only have a small data store and it will never become more than a few, well, let's say 100 items, well, maybe the closing or the activated event is enough. If you have a huge one, maybe you should consider using the page navigated from or even to events. So you can use the unnavigated to or from the unnavigated to events to load the state data instead of a background thread in launching. What I mean by this is if your app is architected in such a way that some parts of your application need some parts of the data store, you don't need to fetch the complete data store on launch. You just fetch those parts that belong to a certain view, and you can do that in the unnavigated to event, eventually on a background thread. You can use loading screen, always helps, just don't make it too long. And you can go even further by splitting up the state data, so you only have to save little pieces of it. In my application that would have been a bit, bit silly, because I only have about 10 items. But if you have a huge data store, in the unnavigated from event, you could only save that item that has been changed on that page instead of the complete data store. That's also good practice. Okay, so far techniques concerning that. Now on to the database. New feature in Windows Phone Mango. This is actually used to store relational data in a local database in isolated storage. We use link to SQL for this. It's in the system.data.link assembly. This is more or less how it looks. Is any of you familiar with link to SQL or the entity framework? Yeah, most of you. Okay. And I probably don't have to explain this in too much detail. I'm going to use the entity framework as an example, or link to SQL. It's all bit more or less the same principle. You're working on your context. This context contains a bunch of tables. These tables have relationships to each other. You can use link queries on those tables, and you submit changes on the context, which will then in turn submit them to the database. That's more or less how it works with link to SQL or entity framework. Okay, it's a very simplified explanation. And it's also how it works with the isolated storage database. But it does require a bit more manual work. If you're using the entity framework, we all know we have that nice designer where we can just drag and drop it. And, okay, I don't like that. But you can do that. Or we can do it code first. But in this case, you will manually have to do some work. You will have to state, well, this entity or this class, in my case, the to-do item class, for example, you will have to state that that one is an entity you want to track with your context, save into the isolated storage database. So you will have to say, well, okay, this entity, my to-do item, that's actually a table. You do that with an attribute. You also have to state on the properties of that to-do item, the IDE, the name, the description. You will have to state, well, those are columns. So you have to use the column attribute on that. Next to that, you also have to manually create relationships between entities. So you will have to add entity references to your classes, so it can be connected with other classes. It does require a bit of work because essentially you're doing what the designer in the entity framework does for you, but you're now doing it manually. Why do you do that then? Well, thanks to a link, it's actually worth the trouble. So, you have a data context. This is a proxy representing the database, and this contains typically a list of tables. You pass in a connection string in the constructor, and you specify the tables in this class. The data context is one part. Then you've got the classes itself, the class that you want to track with your data context and save into the local database. Those should be marked with table, as I just said. That attribute actually associates it with an entity class that's associated with a database table in your isolated storage. And of course, implement notify property changed and changing, just to make sure your UI can get notified. And as we're working with the database, if you're only having unrelated data, it's a bit silly to work with the database. So you need to define your associations as well. This table is associated with that table. This to-do item has that category. This category has 3 to-do items linked to it, stuff like that. How do you do that? On the singleton side, you add an entity reference, and on the collection side, you add an entity set. It's actually should be quite familiar for most of you, I think. And you can also use the entity set constructor to add and remove handlers on what extra code should be executed when an item is added through the entity set instead of the other way around. Again, might sound a bit much in theory, but I'm going to show it to you in a demo. I've got about 7 minutes left. Should be enough. I'm going to go for the completed one here. And then I can just run through the code. It's actually the same application. With that difference that I've added another table. I had in the previous application a list of to-do items. Now I have a list of to-do items with a category. Why? Because I want to have a way to show related data. So in my model, I've got a to-do item, a to-do category, and I've also created a to-do data context. Let's start with this one. It's a class that inherits data context. This data context class can be found in system.data.link. Just create a constructor to pass in a connection string. This is what I will use when my app launches. And I specify some tables. I specify a table of to-do item, my to-dos, and I specify a table of to-do category, my categories. This means I can write code like to-do data context dot to-dos, to-do data context dot categories, stuff like that. Then onto my items itself. The to-do item, I've marked this with a table attribute, as I've said in the slide. And the properties I want to save to my local database need to be marked with a column attribute. Now this column attribute can get some named values passed in, like is this a primary key, is this DB generated, what is the type, to regular stuff you're used to when working with a database. This actually helps a bit, because in my previous application I had to generate an ID, typically, okay, let's take the maximum value. In this case, my ID is automatically generated. I no longer have to create an ID. I just state, well, this is actually an identity column, generate a key for me, and it will happen. The other columns I need to save, name, description, it's very normal code. And this might be another interesting one. I add a binary column named version. Why do I do this? Well, simply because by adding this, your underlying data context, the underlying isolated storage DB, will work a lot faster when you update items. It's actually a quick tip. Just add that column and everything will go a bit faster on update. Okay.
So that's a row version?
Yeah, that's a row version column. And it automatically fills that up. You don't have to do anything to that manually, just add it to your class. And behind screens, it takes care of that for you.
So Java has this one version which is called type version, and this is not a type version.
Java has this?
If you serialize something, you have this version of the type. That's a different.
Type? I don't exactly understand the question, I think.
You can save the storage from one application or another or something, and to make sure that it's of the same software version. So I was thinking that's...
You think to state that this belongs to a certain application, something like that?
Well, because you could have web services and so on, and finally get back object of type, let's say, to-do item or something. You want to make sure it's of the same version.
So that's the state back you might pass in to ensure you get, which one it is.
Yeah.
something like that.
Yeah.
Well, this is actually the raw version. Okay, so a column which aids update performance. And then there's a special part here for the relationships between to-do category and to-do item. In this case, a to-do item can have a category, which means one to-do category can have a list of to-do items, if you put it like that. So, this is the code that ensures my link is possible. I add an entity reference to to-do category, my other class, actually stating one to-do item, one category. I add an internal column where I save the category ID. And this is how I make my link. I actually say, well, this to-do category is going to be stored locally, my to-do item class, in the category variable, this one. This is the key on this side of the association, so that refers to that key. On the other side, that's in my to-do category, there's an ID property. That's the key on the other side, so that's how the relationship should work. And this is, of course, the foreign key. So that's the one side of the association. Let's go to the other side of the association. Again, to-do category class marked with table, columns marked as before. So let's immediately go to this side. The previous side was a singleton side. So this is the other side. First of all, a to-do category can have a list of to-do items. Category A can have a list of 10 to-do items, for example. So on this side, I need an entity set. I have an entity set of to-do items. And the association is simply the other way around. So here I state, well, this entity set of to-do items is stored in the to-dos variable. On the other side of the association, I use the category ID key. And on this side, I use ID of my to-do category. That's about it. I'll immediately go into the handlers I've added. First of all, let's see how we can get this up and running. As you can see, no code in app launching, no code in app activate, no code in app deactivate, no code in app closing. Why? Why do I no longer have to save state here? Well, actually, my state is in my local database. So I submit changes to my database whenever I save, I edit an item or I add an item. That's when I save my changes. So they are saved immediately. I no longer have to save state in between. It's actually simply using a database where everything is stored. I initialize. Let's immediately go here. I check if my database exists. There we go. If not, I create one and add a few categories. Else, I just use that one. So, as you can see here, the logic here and the way of working with it is very much like you're used to with Link to SQL or Link to Entity or Entity Framework. I add a few categories. I say, well, on submit, insert these categories and add them to the categories table. I add a few to-do items, passing in the categories for the link. And immediately going to get into this one. And I submit my changes. That's how you actually add data to your database. How do you load data from your database, from your local database? Just by using link. This is actually pretty simple. Give me all the to-do items from my to-do data context.todos. Same for the categories, and cast them to an observable collection which I can then bind to my UI. Saving changes, persisting changes, simple submit changes. I'm quickly going to run to this one. Adding an item or editing an item, pretty simple. Just edit the entity instance, submit your changes. Adding an item, add one to the entity set, and again submit your changes. Deleting, exactly the same. So there's nothing really special about this. The one special thing, and that's the last thing I'm going to explain, is what about those handlers I was talking about? In my slide I said something, well, you can add handlers to the constructor of your entity set, which are executed when someone adds an item to the entity set. Why would I do that? Well, as you know, you can add, for example, a to-do item in two different ways. My to-do data context has a table, to-do items, to-dos, and I can just insert one like that. There's another way I can add a to-do item as well. This is one way. Add a to-do item passed in the category. You can also say, no, I'm going to take the category and add a to-do item to the to-do items list of that category. It's actually the other way around. That's what I do here. So this is adding a new to-do item, passing in the category to a list of to-dos. And this is taking a category, taking its list of to-dos, and adding a new to-do item, not having to pass in the category anymore because I'm adding it to the list associated with this category. Well, the handlers I was talking about, those will be executed when I execute code like this. What can I do in those handlers? Whenever I add a new to-do item, the category should be linked to that. If I do it like this, I simply pass it in and we're linked. If I do it like this, I somehow need to have some code which ensures that this to-do item will have this category as its category. And that's what these handlers are for. So that was in to-do category. State, instantiate a new entity set, and when an item is added to this entity set, execute this action. When one is removed, execute this action. And what do? Just state, well, once a to-do item is added through categories.todoitems.add, I set that to-do items category to myself. And the other way around, once I remove it, it's set to anywhere else. Like this, those are, well, 4 or 5 lines of code that you have to write, and that will save you the hassle from having to manually put the category each time you add a to-do item to the list through a category. Okay. And that's what we've got now. I can, of course, keep on editing. And there we go. And I will provide you, of course, with all the code so you can look at it yourself. It's actually the same application, adding a category and working with a local database this time. Okay. What else have we got? You can update your database using the database schema updater. That's pretty important when you need to change your database scheme between different versions of your application. You can use additive operations here, so adding a few columns. If you want to do more, you should probably have to write some migration code. You can use indexing to ensure your search keeps going fast. You can actually also encrypt your database. So how do you do that? Provide a password in the creation string, in the connection string, before you create the database. And the next time you access your database, you will need to pass in that password in the connection string, because otherwise you won't have access anymore. Should you use a local database or isolated storage? As far as speed is concerned, you're writing to disk in both cases. It's actually more or less the same. So speed isn't really a consideration to go for one or the other. But what is? It's relational data and querying. If you use a local database, you have a bit more work in setting it up, but you can use link queries as I've shown you. It's a lot easier to query your data using LINQ than by storing everything in isolated storage and parsing it, stuff like that. So for unrelated data, I would still use the isolated storage file stream in this case. For related data, a database is probably worth the trouble. Important to know, your local database runs in the Windows Phone's application process. So it's not like you have a local database on your phone that can be accessed by different applications. It's one database, one application. That's pretty important to know. It runs as long as your application runs. It's not accessible by other applications, and it's not just a background process that's running there as a normal SQL server would be. And you can only access it with link to SQL, so no regular transact SQL queries. Okay. Under the conclusion, application lifecycle, of course, very important for a good user experience. I hope I've shown you that in this session. So do keep that into mind when making an application, because in my opinion it can ensure someone chooses your application instead of one of the competition's. You can use the different states and events to ensure correct and fast loading and saving of your application state. And when you're working with relational data, you could use a local storage database. Okay, if anyone has any questions, I'd be glad to answer them. Yes?
You said before that back button might be interpreted as cancel, but I think the device and the Microsoft code in some cases uses it for accepting the changes. So
Back button for accepting the changes?
Yeah, for example, in the settings, if you change something and you press the back button, the settings are still there.
Those are the, I think that's using application settings on the background, which does automatically save it. But I would not personally do that in an application. If I'm working with, I'm gonna put myself here so the mic works a bit. If I'm working with an app and I push the back button, I expect my data to be gone. Depends a bit, let's say.
You have to read the style guide somewhere.
Yeah, indeed.
Another question was, we were doing this database version linked to SQL, and is it so that you cannot say that foreign key is not null, can't be null, or we were maybe just
that you can say that what that.
You cannot say that foreign key is null, or in the association.
Foreign key is not as far as I know.
You can say it.
Wait. You can say your what are you trying to?
In relational database, you can say if it's required to be some value there, or it can be.
For example, you have a to-do item with a to-do category, and you want to state that it can be empty, and it can be associated with the category.
Yeah.
I'd say that should be possible. I would have to check that in code manually. Okay.
Yeah. So how are you gonna distribute code? It's gonna be available. Code that you
I am going to put everything on my blog today. I have a second session in 20 minutes, I think.
Okay.
After that session, I'm going to put everything on my blog. I think it will be.
We'll at least link to the TechDays site where all the recordings will be. Or we also take those offline and link over there so there's a reference to the blog, but still you can find all the assets from the site.
Yeah. So you'll probably be able to find it on the TechDays site, on my blog, and I'll tweet about it as well.
Through
So.
TechDays site you will find a place where those are.
Yeah. And it should be available by noon or after lunch somewhere.
Yeah, about using the local database. For example, if I have a desktop solution that uses entity framework, what would be the easiest way to get the entity framework entities to your Windows Phone application?
Wait, are you talking about reusing the data from your desktop app, or
use a local cache in the Windows Phone application? So
you want to share data, or
well, I want to make sure the data would be synchronized, but I want to have temporary data for
you want to synchronize the data between a database that's running somewhere online, let's say, and your Windows phone.
Yeah, and I already have an application
Uh-huh.
into the framework. What would be the fastest way to get it?
The only way you're going to be able to access your data from your Windows phone app on a SQL server somewhere out there is service oriented. So you will have to write services to load data, to fetch data using your Windows phone from the server where your database resides or your services reside. And you can fetch that data and put it in your Windows phone app.
Yeah.
But you can't just share data or
Yeah,
like
but,
that.
do I have to build the database by hand, or could I just like copy paste the framework code from?
I'm afraid just copy pasting isn't
Yeah,
going
but
to.
does it need much refactoring?
What are you using link to SQL classes, or are you using entity framework? Link to SQL.
Well, yeah, link to SQL.
Oh, you're probably gonna have to do a bit of manual refactoring yourself, I'm afraid. There are ways to share code between Windows Phone apps and full .NET apps, let's say. You could look into the portable class library project. That's actually an easy way to share code and common classes. That's actually my next session. So, has anyone else got? Yeah.
Okay, I'd like to, if I have an application that has heavy chunk of data or needs some computing before showing some list, and I show first page where user can choose options, and one option is to go to the second page that has lots of data. I put the background thread to work on that second page. What if it's not ready when the user presses and goes to the second page?
Huh. So the threads you're using to do your calculations on isn't finished when the user presses that button. I think more or less the only option there is a loading screen or a calculating screen, something like that. Because if it isn't ready, you can still bind to the object you're gonna put your data in, but it will probably be NLL as long as your thread isn't done. So in that case, it's a long-running operation, and in my opinion, some kind of loading screen is just more or less the only thing you can do. Okay. Yeah.
If you remove application, when the data storage removes as well?
Yeah. If the application is removed from the phone, the isolated storage and local database associated with it is removed as well. Yeah. Okay. If there are no more questions, thank you all for coming. And if you think of something later on, just send me a mail. Thanks.